This section is how to graph functions using transformations. So here are the steps involved. We want to first identify the parent function, plot the parent points by lightly dashing in the parent graph. Next, determine the transformations that occurred in the equation. And thirdly, graph the new graph by transforming the parent points accordingly. If there's more than one transformation, follow the order of operations. Please excuse my dear Aunt Sally, parentheses, exponents, multiply, divide, and then add and subtract. So in that regards, you would apply all of your shifts, up, down, left, and right. You would do those last if there was a stretch, compress, or a reflection that was also occurring. So let's look at a few examples. So we first want to look at the equation and determine what parent graph this is. And I notice that I have absolute value bars here. And so we know that this is the absolute value family. We know that when we see absolute value, we're going to go for that V shape. Okay, and so let's go ahead and look and lightly dash in that parent. So that V shape parent is at 0, 0, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, positive 3. And so just lightly dash in that parent graph so that we know that these are the points that we need to transform. So parent points, I'm going to make them a little bit more obvious here. These are the 7 points that we would move. And then we look back at this equation and we look for the transformations. And so we see this negative 1 outside. And we think back, might look at your foldable, your graphic organizer, your notes, negative 1 outside. And when we multiply by a negative 1 outside, we remember that that is a reflect or reflection over the x-axis. And so we had our little saying, exit outside. So we want to take each of these parent points and we want to reflect over the x-axis. On the x-axis, this point's going to stay. A positive 1 turns into negative, negative 2, negative 3, negative 1, negative 2, negative 3. So we've reflected all of the points over the x-axis, and we draw our equation, our graph, back in. Example number 2. We look at the equation and we pick out the parent. This is the cube root. And when we see the cube root, we know that this is our horizontal S. Okay, so we have our parent points of our horizontal S, 0, 0, 1, negative 1. And we know that we're going to head up towards the 2. And then our half U headed back down here towards the negative 2. However, I did not dash that in. And it's really important that you dash this in so that when I'm grading or when you're grading, you can look back and say, okay, this was the parent, and now we want to transform it. And so we have a plus 2 outside of this equation. So our parent equation here is just this cube root of x, but I have this plus 2 outside. I know that it's outside because this cube root bar is not being extended across. And so when we add or subtract outside, that is when we're shifting up and down. And since it was a plus 2, we know that we're going to shift up 2. And so we're going to take each of these points and shift it up 2. So 0 would go up to 2. This point at 1, 1 would go up 2. At negative 1, up 1, 2. So now I'm going to have my half u headed towards this 4. And then my half u is going to head down here towards the x-axis. And so there's my cube root shifted up 2. Example number 3. I look at this and I see that my parent is the exponential equation. I know it's the exponential because the x is in the exponent spot. And that parent starts at 1 here on 0. So then 2 to the first is 2, 2 to the second is 4, and then over here I have 2 to the negative 1 is a half, 2 to the negative 2 is a fourth. So I'm going to dash in my parent here. And my transformation is multiplying by 1 half outside. So that is multiplying by a fraction between 0 and 1, and so we know that we are going to compress by 1 half. So vertically compress. I need to take all of these parent points here and vertically compress down by a half. So 4 is going to turn into a 2. 4 times a half is 2. 2 times a half is 1. 1 times a half is a half. Then my 1 half turns into a fourth. And my fourth would turn into an eighth, which you really couldn't see the difference between that and the x-axis most likely. Still not going to cross the x-axis when I draw in my new transformed graph. So I'm going to head up here through my parent points, exponentially curve up, and then my curve is going to head down here towards the x-axis. And so my red graph here is my 1 half 2 to the x, so it's compressed by a half. And our last example here is y equals x minus 3 to the third. And so this x to the third is going to be the cubic or the cube function. Okay. And so my parent graph is the vertical S. And so I'm going to start here at 0, 0, 1, 1, negative 1, 1. So those are my parent points. Dash in, I'm going to head up towards the 2. And my half u is going to head down towards this negative 2 line here. And now my transformation that I'm noticing is this minus 3. Now it's inside the function because this cube is being applied to it. So it's a minus 3 inside. And so when we're inside the function adding and subtracting, we know that we're going to be shifting left and right. And inside the function, it's a little bit opposite of what you think it's going to be. So minus 3 inside is we're going to shift right by 3. And so I'm going to take each of my 3 parent points and shift right 3. Change colors here. 3, 3, and 3. So my graph, I don't really have enough room, but I'm going to go ahead and draw it in like I can. Half u up, and then I'm going to take my half u and head down towards this 1 line here. And maybe I could have done a little bit better here with my half u. Let's see. Parent point, and head up. There we go. And so if you are able to follow these steps here, find the parent, plot the parent points, look for that transformation, you will be successful graphing these new graphs using transformations.